Welcome, Applefreak. They're from the University of León and Tubaf. And the one presenting are going to be Celia and Rubén. Please, welcome to the stage. They are finding a solution for the challenge number 13, which is develop an eco-friendly solution for apple harvesting, avoiding fruit or tree damage without the use of human force. From Bayer.
Hi, I'm Rubén.
Hi, I'm Celia, and we are part of a multidisciplinary team. We work on the STEM challenge about developing an eco-friendly solution for apple harvesting, also avoiding apple and tree damage. So we form, the members of the team are from different branches, such as environmental sciences, computer engineering, and industrial engineering, and we are part of the University of León and the University of Freiberg.
Well, and the challenge we are doing is to develop an easy-to-use device that can be controlled remotely, that is also eco-friendly, and that uses AI for the system for collecting apples.
Okay, so in Spain we have a saying that it is an apple a day, it's the doctor away, and that is why the pharmaceutical enterprise Bayer, which suggested this project, studies the uses of the apple for things such as cardiovascular diseases or blood sugar regulation.
So you're telling me that apples has so many uses?
Of course, we also buy the apples in the supermarket, we eat them as so, and we also use them for many elaborations and in cooking, for example.
Yeah, and
that's why
yeah.
we thought of this project for more sustainable. So we wanted to take advantage of as many apples as we can. So we don't just get perfect apples. We also get that ones which can be revalued for other elaborations or for cooking.
So that's all you think you need to think about?
No, we also need to study many things for example, ramification of the trees, or we also need to thought about the structure of the zone, the M106 distribution of the trees. We also studied more than 25 plagues and illnesses, and that way our project can prevent many tons of apples from getting wasted when harvesting. So that's a really good advantage for agriculture.
Oh, okay, I understand, but for example, I cannot climb trees. How are we going to recollect those apples?
Yeah, we need to think a little bit that old traditional way of shaking the trees, because that way the apples got wasted. So we need something to think about getting the apples from the tree.
Yeah, I don't think we need to do it manually when we can use, for example, 5-star motors connected with an AI system that has been trained with, for example, hyperparams like 100 epochs, a learning rate of 0.00.
Wait a little bit because I'm not understanding that.
Okay, sorry, I was just too excited. I was just telling you that we need something to detect the apples, and also to detect if those apples has illnesses, and of course if the trees could have some illnesses too. So we can use an artificial intelligence system to do that.
But will the apples teleport there, or how are we gonna get them?
Well, no, we don't have the technology to do that. We could, for example, use a drone.
Yeah, but if it goes flying, it wastes a lot of energy. I don't know if the battery would last so long, and also how it may get stuck in between the branches of the trees, or we need to think another.
Yeah, I think you're right. I have another idea. We could use, for example, a four-wheel vehicle that it can go through the surface and can collect the apples using two arms that detect the apples through a camera system.
I like that, but we need to think again about the energy. 4 wheels mean 4 batteries and 4 motors, so
That's true. We could use, for example, instead of 4 motors, 2 motors.
So it's like a boogie.
Yeah, that's a rule. Yeah.
Okay, but our boogie needs to be lighter. Maybe we can use another thing.
I think we can use another material. We could use aluminum alloy.
Oh, I like
example.
that because it's also like you can recycle that. So it's more sustainable for all us. Talking about the power, I mean, how are we gonna charge the boogie?
We could use, for example, an outside point, an external point, in which we can put, for example, a solar panel that can charge the batteries of that vehicle.
Okay, I like that. So I think we really,
I think Palash like it too.
yeah, I think we did a great job, but it's a little bit complicated, don't you think?
No, I don't think it's too much complicated. For the surprise, we have already a prototype done. We can have some space.
So this one from here, the solar panel.
Yes, that's in the solar panel. And this is just as a decoration. And of course, the apples.
Okay, so I think we have our project all thing, but I mean, we already have an easy-to-use device. You can use that it's autonomous, so you don't have to do anything.
Yeah, that's true. And it also follows the 4 step we have put in our project. The first one is that it must move to the trigger. As we can see in the video, it can move.
Wow.
The second step is that we need something to detect the apples, for example. And in this case, we can use, for example, the Olympic ones that is called YOLO. It's an algorithm to train an artificial intelligence that can recognize several objects that in real time. And here we have a test about this model that, as you can see, it can recognize apples, but it has some errors.
Okay, it's normal because there are like more than 25,000 of varieties of apples. I mean, there are many colors, many forms of the apple. So you mean that if we give this robot more information, it will have less errors in the system?
Yeah, and we only have used 150 samples of apples.
So if we give, like, for example, 10 times that information, if we train this little robot, it could like detect more efficiently?
Yeah, that's for sure.
Okay.
And then the step 3 is that it needs to locate and direct the arm to the apple. You can see this is a demonstration of its movement. Right now, the system is already loading the model that can recognize apples, and we will see a demonstration about how the arm follows what the camera detects. For example, in this case, it has to be apples. Then I think right now it should have been loaded. So let's test it. Let's see here. Oh, our response. Now I'm testing, for example, in x-axis, it follows it well. it has some time between each detection. That's why it's so slow to follow. But it's, as you can see, it can follow the apple. And now, if you want to try and see how it works,
You need to hit stop. You choose a place, and it will follow.
you can put it more close. Yeah.
No. So now you can test with the hand. So it's not gonna follow a hand or another object. So it won't move if you put anything that is not. Okay.
And now for the step 4. Oh, it has seen the apple. Okay. And now, for step 4, this is the stage we haven't reached yet. We need something to let the system know where the apple is, depending on where the vehicle is, where the arm is. One thing we were thinking about is using a Doppler, for example, to calculate the distance between the apple and the arm.
So is that little thing from there?
Yeah,
that can calculate like the profundity of the apples, or
you can calculate the depth. It's used to calculate the distance.
Okay, so I think like we already have the autonomous robot. I mean, we also have covered like many sustainable points. All we thought about. I mean, you can recognize the apple and select it in order of the use. You can revalue it, or you can also charge it with solar panels, which is also really a good impact on the sustainability. So
yeah, and also it can be controlled remotely, because we are using a Raspberry Pi that is a board that can be used to many remote projects. For example, we can control it through web and also through an application, a mobile application. And we also use artificial intelligence, as you have seen, to detect the apple.
okay, so yeah, I think we did a great job.
Yeah, that's for sure.
And now I think we need a name for this.
A name? Yeah, I was thinking about a name. How about we call it Apple Harvesting Collector with AI?
It's a bit difficult, and I don't think it likes it.
Oh. Then what's your idea?
Maybe apple craft?
Apple craft. Yeah, I think I like it, and it's also it also represents our theoretical model.
Yeah, and I also think he likes it.
Yeah. Okay.
So so thank you all for listening to us. And now, if you have any questions, we're here to listen to you. So.
Thank you very much. Professor Rosario, you have the word.
Yeah, thank you. I'm going to put Palash there.
It's because Palash is not here, so
He's in Brazil, so he cannot.
Palash, switch on the camera. Yeah. Can you see the trial? Yeah.
Now we have 3 members,
Yeah.
3 team members.
So thank you, first of all, for the presentation. How do you see your eco-friendly apple harvesting solution being adopted in the industry? Have you considered any barrier or challenges to implementation, and how do you plan to overcome them?
I mean, you just have to think about, for example, Rumba, which are enterprises which use the robots like cleaning assistants, is like the same economical value it can have, but for agricultures. I mean, it's like the similar commercialization, so it's just an agricultural system so that it can work on the field while it can provide you for more, you can have more capacity of production as you don't have to work by hand all the fields that you have. Of course, you can still work by field on some zones, but you can approach more with these robots. So.
Yes, for example, with technical problems, as I was saying, we didn't have much time to prepare the prototype, so we didn't do the part of the detection to calculate the distance, and I think that's an important part. And also, we were thinking about taking the camera the real prototype, let's say, to put it in the arm so it can detect apples and also move to those apples.
So
That's a challenge for sure, because when we were thinking putting the camera on the arm, there was some problems in this case with that, because we were thinking and using just the detection of the apple to recollect the apple, but then we see that we cannot do.
I mean, this is like theoretically it's everything done, but in practice we don't have that much time for making a whole robot with the Doppler and so that if you can put the Doppler and put the good camera, because that's not like the best we can buy. So if you can put a good camera on the front, it could like detect the profundity, and also it can in the arm the distance it can have a better vision of the apple. So it will work better, but we can do it all practical because it's like a big thing. So.
Thank you. Thank you so much. Okay.
Okay, my question will be such a kind of contradiction because congratulations for the realization of this prototype. You can find here many skills of application about the mechanics, the sensors, data treatment, and so on. I'm not sure that it will be suitable for the apple harvesting because I think you can have apples one by one and it needs many times, so it's very complicated, but I'm sure that for other applications it will be very, very useful.
We also thought about it because it, well, this not, but the big one could have like a basket, and it also can, it can support like 300 kilograms of apples. So it's all calculated so that it doesn't have to do like many goes. It just in one go with the arm, it can collect the 300 kilograms, so that you have all collected by one.
Did you check about the life cycle analysis, like the duration of the application? Maybe
The what?
Have an idea about the duration you can use?
Yeah, with do you mean the battery or?
Yeah, all the system.
Yeah, we also were thinking about an automatic program that when the system detects that the battery goes below a certain point, it calculates its route to its path to return to the point of charge. For example, we were just thinking, we thought about that too.
That's why we didn't choose the drone, because it will be really.
And for example, about the part of this, for example, the artificial intelligence can have some errors. For example, it can take an apple that cannot be eaten in some times because
Like
you
the
are
selection
just we are just collecting apples given a certain point. That's I think it would need human labor to detect if those apples are or not.
Okay,
Con
thank
volumen.
Que seguramente que
Palash. I don't know if you
But you can repeat
to it. Like, if you wanna talk about the design, about the
Why
artificial
don't you
intelligence.
bring him to us?
Oh, okay. Wait. Because he knows a lot more about the recognition of the apples because he's the one in artificial intelligence.
So, yes, sir. About the design specification. So, yes, we have calculated the power required for the it was about 8 kilowatt per half per kg, and we can carry about 300 kilograms. For that specification, we have designed this equipment. I am not sure I have. Were you able to see the design? You can see.
in the book. He's saying that if you can see in the book, then
Yeah, that in the
Ah,
have the design.
then all the technical aspects are in.
Okay.
It's that he is not seeing what we are seeing.
Also, there are some calculations.
Oh.
A difficult one.
Yeah, and also of course, like maybe you see the apple just in one image, and you have just one perspective for the apple, but that's nothing we can do about it. I mean, it's a camera, it's nothing. Just a human eye could detect that. So once you have the apples collected, it's a little it's a little percentage of the apples that can be damaged by 1 point. So it's just review the agriculture need to do of the apples collected. But it will be like a work that he will already do, as you have the cleaner system at home, and you also need sometimes to go through the little corners. So it's nothing that we could do about it, but I mean.
Okay, Professor.
Yeah. It's gonna be on the factory side, something that you can do as an add-on. First of all, congratulations on your work, and come from the robotics side. But there's a lot to do to scale it up. It's not an easy task. And thank you for calling Raspberry Pi Raspberry Pi, because it's the right way in the Greek language. So P is the Pi. So I would like to ask you, why are you choosing the Doppler? I don't know what you're meaning with that. Why not using a dual camera, stereo camera?
Yeah, it's because it's like we already had that camera because it's like material that we could have access to. But if you could have like an integrated camera with profundity, it would be better, of course.
I mean, why not stereo camera and Doppler processing?
Well, the Doppler, we use a Doppler. We were thinking about using a Doppler in the prototype, for example, to just ask like an example of what the real part would do, for example. But for the real model, for example, I was thinking about using LiDAR, because it can also detect the form, the shape of the apple, and it will be good to use it also to detect where the apple is and how and also how the size of the apple to recollect it, for example. Because calculating the size depending on just a camera, for example, it would be a difficult task.
Try to see a stereo camera also. It might help you in the implementation. It's much cheaper. I'm not sure it's gonna fit. Thank you.
That's my turn. You know, every September I do apple picking because of it's customary in my region, which is a region nearby, to produce cider. So the friends gather to pick fruits, in this case apple, and make some cider. The main concern in this case would be branches. When you have to pick an apple, they are going to be around in 3 dimensions. So there is a lot of work. I think you have done a lot of work here, specifically made for this contest. But as he said, there is still a lot of work to do in this case. But maybe with this prototype you can pick other fruits in the field easier than apples because they are a 3D problem. Maybe I don't know, watermelons would be easier, of course, but there are other fruits easier to pick with this model rather than going straight away for apples. But
yeah, many of the information was also, I'm from Asturias, which is written about this. So there is where cider is made, and many of this information and the idea was by the information of my neighbors, which are cider elaborators. So this will be like an assistant. Of course, we don't have the capacity to do the whole assisted process, but it will be able to catch. I mean, we studied the ramification of the trees, and so that this arm has many flexures, and he can explain to you. It has like 4 articulations or so. So that is the more effective one we could thought about, and also there is still like the traditional way of shaking the tree and getting the apples from the floor, but that way is where apples get damaged. So with this we could add more.
for cider you can do it, but for juice it would be not possible because of contamination.
Yeah, of course we studied the uses.
Cider could be good for apples. Okay, thank you very much for your presentation.